All right, so what do you want to take a look at first from yesterday? 32. All right, well, let's see here. On 32, directions tell us to sketch the region whose area is given by the definite integral, and then use some geometry to figure out what the definite integral equals. So they give us this. All right, so f of x then must be that, right? Okay, so what's that going to be? And especially if you look back at number 31 that you did, that's going to be a semicircle, isn't it? Okay, so if that's a semicircle, I mean, think of it this way. You've got y equals that. You square both sides. Right? So, zip, there's the graph. So the radius is r. So if it's centered at 0, and it is, because remember the x minus h quantity squared, y minus k quantity squared for the circle. So if the radius is r, you'd have to go r to the left, which would put you at negative r to the right, which would put you at r. So you got a semicircle. And now, to get the area, well, it's a semicircle. So the area of a circle is pi r squared. So the area of a semicircle is 1/2 pi r squared. R is r. Done. All right, does that take care of 32? All right, what else? 44. On 44, we are given that the integral from -1 to 1 of f of x dx is 0, and that the integral from 0 to 1 of f of x dx is 5. Now, before we even answer any of these questions, this actually is logical, and I want to say common sense, but it's not common, right? Because most people can't do calculus, but it makes sense if you think about it. Okay, so it's not common sense; it's uncommon sense, but it's sense. So if I've got a graph here, all right, and it goes from -1 to +1, and the integral is 0, doesn't that make you think that either there's nothing there at all, right, or there's just as much of the region below the x-axis as there is above the x-axis? Does that seem reasonable? So if from 0 to 1 I have a distance, or I have an area of 5, wouldn't it seem reasonable to think that, and look, I don't know that's how it works, do it. Okay, I don't know what the graph looks like. They don't tell me what f of x is. But if that's correct, what would be the signed area of that piece right there below the x-axis? And that would give us, that would make that work, wouldn't it? Okay? So, let's see how it all works out. So for part A, they want us to find the integral from -1 to 0, which is what I was just kind of figuring out graphically, isn't it? All right, one of our properties of definite integrals is that we can add pieces together, okay? So the integral from -1 to 1 of f of x dx can be broken down into as many different definite integrals as you want. I can break it into 2 definite integrals and add the pieces together. I can make it 10 definite integrals and add the pieces together. Just depends on how big the intervals I want, okay? But I can do 2, right? I said I could do 2. I can do 2. So how about writing that as the integral from -1 to 0, which I don't know, but I'm asked to find, plus the integral from 0 to 1. If I go from negative 1 to 0 and then from 0 to 1, doesn't that get me from negative 1 to 1? See how it's, I mean, it's just as if it were on a number line, right? Negative 1, 0, 1. If I go from negative 1 to 0 and then from 0 to 1, isn't that the same thing as going from negative 1 to 1? Okay? Now look what this has done. It's almost an algebra problem because we have three things in our equation. We have three separate definite integrals. Well, we know what two of them are. We're told what two of them are. If you've got an equation with three things and you know two of them, can't you always solve for the missing one, for the unknown? You can. That's what we're going to do. All right? So, that one's the unknown. The integral from 0 to 1 of f of x dx is 5, so substitute 5 in. The integral from negative 1 to 1 of f of x dx is 0, substitute that in. And then solve for that unknown definite integral. So, we subtract 5 from both sides, and lo and behold, what we thought graphically is true. The integral from negative 1 to 0 of f of x dx does equal negative 5. Now that we know that, can we use it if they ask us to? Sure. And you'd better. So then we go to part B, where they want us to find the integral from 0 to 1 of f of x dx minus the integral from negative 1 to 0 of f of x dx. We know both of those. Substitute in and simplify. The integral from 0 to 1 is 5, so you put that in. You copy down the minus sign. Then the integral from negative 1 to 0 we just found, that's negative 5. Substitute that in. And now we know that that simplifies to be 10. C wants us to find the integral from negative 1 to 1 of 3 times f of x dx. Are we allowed to factor out constants? Yes. Okay? We're allowed to factor out constants in sums, in limits, in indefinite integrals, and in definite integrals. We can always factor out a constant. Okay? So, we factor out the 3 and put it in front, and now we know that one. That definite integral equals 0. How do I know that definite integral equals 0? Yeah, they told me right there. So 3 times 0, 0. And then part D, the integral from 0 to 1 of 3 times f of x dx. So go through the same process. Factor out the 3, put it in front. We know what that integral equals. So substitute the 5 in, you get 15. See, when you watch the video, you'll never remember that I sneezed right in the middle of it. Unless, of course, I didn't handle the microphone right and the sneeze is on there. And this part's not. In which case, you won't know that I'm talking about. Okay. All right, what's next? All right. All right, I think this is what may be getting you. In the direction, they tell us to use 3 equal subintervals. So, if you're going from 0 to 6, your 3 equal subintervals, you would go there, there, and there. So the end point, so if this is on a number line, 0, 2, 4, 6, that's 1, 2, 3 equal subintervals, isn't it? Yeah. So that's what's getting you. Does it matter how many intervals you use? Yeah. Sure does. So that's what got you, isn't it? All right, I'm glad you asked that then, because that's easy to fix. So let's go over this though. So for the left-hand sum, our first interval goes from 0 to 2. The left-hand sum means use the f of x that comes from the left edge of your interval. Well, there's the left edge of my interval. There's the f of x that goes with it. So since we're doing 3 equal subintervals, the width of each one is 2, isn't it? Remember this? 0, 2, 4, 6, 1, 2, 3 subintervals. So the width of each rectangle is 2, and the left edge of the first one has an f of x of negative 6. So that's the first rectangle. So signed height, signed area for that rectangle. All right, then the next interval goes from 2 to 4. So the left edge of that one is 2. The f of x that goes with it is 8. So that gives us the area of our next rectangle. And then from 4 to 6, 4 is the left edge. 30 is the f of x that goes with it. Do the arithmetic. To get the right-hand sum, all right, now when we go from 0 to 2, 2 is the right edge of the interval. Its f of x is 8. The next interval, 4 is the right edge. Its f of x is 30. And remember, why are these 2's down here? Because that's the width of each rectangle. That's the base of each rectangle. And then for the last interval, 6 is the right edge. Its f of x is 80. Do the arithmetic. And then midpoint. Well, the midpoint of that first interval is a 1, isn't it? The f of x that goes with that is 0. So there's your first signed area of the first rectangle. All right, for the second interval, the midpoint's 3. There's the f of x that goes with it. For the third interval, your midpoint is 5. There's the f of x that goes with it. And then you can compute the area, well, the sum. Okay? Now, like I've said, that seems to be becoming more common on the AP test than the upper and the lower. But it's the same idea, isn't it? Okay? You're either going by the appropriate edge, or when you're doing upper-lower, you're going by the lower f of x or the upper f of x. Okay? Yes? Correct. Exactly. Exactly. All right, we okay with 46? Yeah. 49. 49 what? C and D. Am I going to regret not doing A and B before we do C and D? Or can we jump to C and D? Y'all worked these last night. I didn't. Oh, 2 nights ago. All right, 49. We're given that we have the integral from 0 to 5 of f of x dx equals 4. For part C, we're told that f is even. Now, you probably don't remember what that means, all right? But it means that it's symmetric with respect to the y-axis. You may not remember what that means. All right, if that's your xy plane, that graph is symmetric with respect to the y-axis. Okay? The y-axis is a line of symmetry. The graph to the left of the y-axis is a mirror image of the graph to the right. Okay? So if that's the case, wouldn't the integral from negative 5 to 0 and the integral from 0 to 5 give you the exact same area? Now, the example I drew up, that, wouldn't the blue region and the black region be the same? Okay? So, when you know you have an even function, you can use that to your advantage. So they're wanting us to find the integral from negative 5 to 5. Okay? Since, and they didn't tell me this, I figured this out because I know what even means. So you do need to know what even means. That'll be on the AP test as well. Okay? So since I know what even means, and I know what symmetric to the y-axis means, then I can figure this out. I don't have to have a theorem. I don't need somebody to tell me. You can't. That's true. That means the integral from negative 5 to 5 can be written as the integral from negative 5 to 0 plus the integral from 0 to 5. Both those being f of x dx. okay? And they told us what the integral from 0 to 5 is. We figured out the integral from -5 to 0 is equal to it, and then we add. No, opposite sign comes in when you do that and switch to that, when you flip them. I didn't flip the limits of integration. Yeah. All right, see, makes sense? Now that you see how that's done, that's doable, isn't it? Okay? It needs to be doable. It really does. That needs to be doable. All right? Now, on part D, they tell us that F is odd. You probably didn't remember what that meant. Odd means that it's symmetric with respect to the origin. What's that mean? That means if that's your XY plane, that there's just as much stuff below the x-axis as there is above the x-axis. Now, it could be the other way around. It could be, that and then that as far as odd. But it's symmetrical with respect to the origin. Okay? But in other words, the line of symmetry would be y equals x. Okay? You knew this at one point in your life. You really did. Because that's not what odd means. In fact, a function can't be symmetric with respect to the x-axis because it's not a function. Okay? So, if that's the case, like the one we just did a few minutes ago, won't the signed areas just be opposites of each other? That red region and that red region, their areas will be opposites. Like the one we just did, it was 5 and -5. Or if the graph looks like the blue one instead, because I don't know which it looks like. They didn't tell me. I mean, I guess I'm going to figure it out. I don't know. But that blue region and that blue region will have opposite signed areas. All right. Since that's the case, then I know that, don't I? That the integral from -5 to 0 of f of x dx and the integral from 0 to 5 of f of x dx are opposites. So put a negative sign in front of one of them. Does it really matter which one? Not really. We just know they're opposites. Okay? So how can we rewrite the integral from -5 to 5? Well, like we did on part C, make it the integral from -5 to 0 of f of x dx plus the integral from 0 to 5 of f of x dx. But this time, since they told us, and I'd forgotten they told us this, but they told us that the integral from 0 to 5 of f of x dx is 4. So in other words, the graph looks more like the red one than it does the blue one, doesn't it? Okay, because from 0 to 5 is the positive signed area. So if from 0 to 5 is a positive signed area, wouldn't this one be a negative signed area, the opposite of it? So, and you get 0. In fact, as long as your limits of integration are the same distance away from 0, the integral from, let's put it this way, the integral from -a to a, following me, from -a to a of f of x dx when f is odd will always be 0. And when it's even, it'll always be double. Yeah. All right, part B. All right, we've got the integral from -2 to 3 of f of x dx. No, of f of x plus 2 dx. Let's see, what did I do here? I did a vertical shift, right? Is that what I'm doing? Y'all had pre-cal more recently than I did. What did I say? Horizontal, yeah, horizontal sideways. See, that's new. It used to be the, okay. All right, if that's f of x, then that's f of x plus 2. They were supposed to look identical. Actually, am I shifting the right way? Shouldn't I shift? No, that's the right way. Right. So I'm just adding 2 to the limits. All right. Anything else? All right, 51. All right, they give us a graph on page 280, and we're supposed to use that figure to put a less than, greater than, or equal symbol. So they give us this, and we have to decide if that's a less than, greater than, or equal that goes between them right there. So they give us a picture. It says the interval from 1 to 5 is partitioned into n subintervals of equal width delta x, and xi is the left endpoint of the ith subinterval. All right, they ask us if the sum is greater than, less than, or equal to the integral. All right, our picture looks like this. And if xi is the left endpoint, so we've got a bunch of intervals, right? Did they tell us how many? They don't. So, right there is xi. It's the left endpoint. All right, so let's see. So that means that would be the f of xi. And since this function is concave up, I'm going to get a rectangle that's a little bit above, the top of it's a little bit above the graph. Because since they told me that xi is the left endpoint of the interval, if that's my interval, xi is the left edge of it, so you follow it up, that's the f of xi, then you make the rectangle, since it's concave up, it's always going to be like that, isn't it? See what's going on? Since it's concave up, and it's always concave up. If they do some up and some down on us, then we really need to know where the interval is. But if it's always up, then the left-hand sum, which is what they're telling us, right? Since xi is the left edge, we're getting our left-hand sum. The rectangle, the top of it's always above the graph, so that sum will be greater than the actual area. Follow me? Make sense? Yeah, the left hand can be less if the graph is different. If the graph is, let's see. No, it changes. Wait a minute. It needs to be increasing. Yeah, if it's increasing, if that's xi, then it's below. So it was the decreasing. It wasn't the concave up. It was the decreasing. Okay? I had the right reason. No, I had the right solution, wrong reason. Yeah, left-hand limit will sometimes be upper, sometimes it'll be lower. That's where you need to either see the graph or a table. Okay? Everybody with me on that? So left hand can be upper or lower. Right hand can be upper or lower. Midpoint can be upper or lower. Well, midpoint actually, yeah. Okay? So you either need to see a graph or see a table. All right. We done? We're done.